Equilibrium review questions. First, we looked at K, which was a temporary equilibrium constant just before we canceled out the pure substances that have a state of solid or liquid. And then after that, it becomes KEQ, which is the permanent, I'll just put here permanent, quote-unquote permanent equilibrium constant. Remember, the equilibrium constant was the ratio between the concentration of the reactants and the products to see where it's going to shift. So KQ is a blanket term, okay? So this general blanket term branches down into KP and KC. We know KP, right? What's the equilibrium constant of partial pressure? They're specifically used for gases, which we'd like to use them for. And KC, however, is the equilibrium constant when we deal with concentration of molarities, okay? So when we look at this kind of question over here, we see mole times L to the -1. What is that? Well, L to the -1 is just 1 over L. Mole times 1 over L just gives you mole per liter. So obviously we're dealing with molarity. So we are dealing with the KC, okay? Next, we're going to be looking at an ice table. Obviously, our reactants for our initial concentrations were not given, but obviously the SO3 has to start at 0 initially, so we've written out as such. This is our chains based on our coefficients in this chemical equation. We've added them up in the equilibrium. We get 0.27, 0.40, and 0.33. Again, all of these must be in moles per liter because we're dealing with molarity. So we're going to be using Kc as our variable here. We have our products on top, our reactants on the bottom. We're just filling them in. So 0.33 goes on the top here. Then we have 0.27 over here, and then 0.40 we're going to be having to add it over there. We end up getting Kc is equal to 3.73. So if 3.73 is greater than 1, because we know that if KEQ is greater than 1, what is favored? The products end up being favored. Okay, if K is less than 1, then the reactants are favored. Okay, so that's what we look at when we deal with KEQ. But what about QEQ, which is our reaction quotient, so that we can see which one is in greater amounts to see? Is it going to shift to the left or is it going to shift to the right based on the Chatelier's principle? Again, we have video links in the description if you have no idea what I'm talking about here regarding KEQ and reaction quotient. See the links in the description where I go into detail about this stuff. So what about the QEQ? Well, we can't solve this about QEQ because QEQ is the reaction quotient. We have to do it in such a manner using this formula, but we should be given the Kc. That's not the case in this question. In this question, where we're trying to find the Kc, okay, so we've just found it over here, so we can't use our QEQ. In the question that I'm going to be giving you for you to try yourself shortly, we will be dealing with a question where we have to be finding the QEQ when given the Kc. Is the green question of the day. Please give this a try on your own, and I'll be giving you the answers shortly. This is the answer.